Laboratory exercise number 2. Kinetic and chemical equilibrium. Objectives. At the end of this experiment, you are expected to first, make and record observations, measurements and approximation. Second, interpret and evaluate experimental observations and data. General direction. Study the two experimental setups. Answer what is asked appropriately. Number 1. Identical pieces of brass were placed in two different boiling liquids for 12 hours. The graphs show how the mass of each piece of brass changed. So the graph A is the brass in boiling acid solutions and the graph B is the brass in boiling basic solutions. So here is the graph. Questions? Give one similarity in the change in mass in the brass in both liquid. They are able to change in mass in given time. B. Describe two ways in which the loss of mass shown in graph A is different from that shown in graph B. In graph A, it shows a continuous slope up until 12 hours, and on the other hand, graph B has changed in slope when reaching the 9th hour until 12 hour. Graph A shows a slower rate rather than graph B, since it has a 60% slope. C. List 3 different safety precautions that are needed in doing this investigation. First, we need a gloves, a goggles, and a lab coat. 2. The rate of reaction between hydrochloric acid and aqueous sodium thiosulfate was investigated. When these chemicals react, they form a precipitate which make the solutions go cloudy. The formation of this precipitate can be used to show how fast the reaction continues. 5 tests were done using the tools shown below. So here is the tools. The I, 10 cubic centimeter of hydrochloric acid, 500 cubic centimeter of conical flash, aqueous sodium thiosulfate, and pretty. Test 1. Using a graduated cylinder, 60 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flash. The conical flash was placed on a printed sheet of paper. 10 cubic centimeter of the hydrochloric acid was added to the solutions in the conical flash and the stop clock started. The time taken for the printed words to disappear from view was measured. So, test 2 is using a graduated cylinder, 50 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flash, followed by 10 cubic centimeter of distilled water. The conical flash was placed on the printed sheet. 10 cubic centimeter of the hydrochloric acid was added to the solution in the conical flash, and the stop clock started. The time taken for the printed words to disappear from view was measured. Test 3. Test 2 was replicated using 45 cubic centimeter of aqueous sodium thiosulfate and 25 cubic centimeter of distilled water. Test 4. Test 2 was replicated using 35 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. Test 5. Test 2 was replicated using 10 cubic centimeter of aqueous sodium thiosulfate and 20 centimeter of distilled water. Question C. From your graph, infer the time of the printed words to disappear in test 2 was repeated using 15 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. Show your solution on how you come up with the answer. I got 125 seconds for printed words to disappear from the 15 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. In which test was the rate of reaction greatest? Explain why the rate of reaction was greatest in this test. Test 1, because the acid is oxidated due to absence of water. It was able to erase the print in matter of seconds.